Welcome to this presentation on AI-assisted development. You've probably seen those studies claiming that AI makes developers less productive or write worse code. Well, if you're using a hammer to turn screws, of course you'll get poor results. Today we'll explore what actually works in practice, and more importantly, I'll show you how to use these tools correctly. But first, let's get one thing crystal clear. AI doesn't write code. Developers write code. Whether you're using IntelliSense, Stack Overflow, or Claude, you are making the decisions, you are reviewing the output, and you are responsible for what goes into production. These are tools that assist your development process, not replace your judgment. I'm going to walk you through 4 approaches that build on each other. But more importantly, I'll show you where each one actually works, where they fall flat, and how to combine them into a systematic approach that actually improves your productivity. Here's the reality. Most developers are using AI tools randomly and wondering why they get inconsistent results. They paste code into ChatGPT without context, accept autocomplete suggestions without understanding them, and then blame the tool when things break. The 4 approaches we'll discuss today aren't separate techniques, they're building blocks. Each one teaches you something essential about working with AI effectively, and they combine into a systematic approach where you maintain control while leveraging AI's strengths. These approaches are autocomplete, task-based, conversational coding, and systematic integration. Each has genuine use cases and important limitations. But understand this. In every case, you are the developer making decisions. The AI is just another tool in your toolkit. Let's start with AI autocomplete tools. These are where most developers begin their AI journey. Tools like GitHub Copilot, SuperMaven, and Continue in its autocomplete mode work directly in your editor, suggesting code as you type. They feel magical at first, but understanding their limitations is crucial for using them effectively. Here's something that might surprise you. In well-structured projects with good typing, traditional IntelliSense often gives better results than AI autocomplete. If you have a properly typed TypeScript codebase, your regular autocomplete knows your exact API surface and available methods. iAutoComplete has to guess based on patterns from its training data and frequently gets your specific API wrong, suggests deprecated methods, or invents functions that don't exist in your codebase. The fundamental limitation is context. These tools only see a small window around your cursor and miss the bigger picture. They don't understand your domain model, your coding standards, or your API design principles. This leads to suggestions that are technically correct, but architecturally wrong. Autocomplete works best for certain types of code. Boilerplate and patterns you use regularly. Test templates that follow your established structure. LPI, calls to well-documented services, and converting between similar data structures. But don't expect it to understand your business logic or maintain consistency across a large codebase. When you need more context and control, that's where task-based AI comes in. The second approach is task-based AI, where you post specific problems to models like Claude or ChatGPT and get complete solutions back. This is where you need to start understanding how these models actually work, because the settings you choose dramatically affect your results. Here's where most developers hit a wall. They're using AI services with default settings that weren't designed for their specific needs. Services like ChatGPT and Claude hide most of their configuration options, but understanding parameters like temperature, which controls creativity versus consistency, is crucial for reliable results. Lower temperature gives predictable output. Higher temperature gives creative but inconsistent responses. And this is just the tip of the iceberg. If you want to become truly effective with AI, you need to understand system prompts, sampling parameters, and much more. We'll touch on this throughout, but know that mastery requires going much deeper. This works brilliantly for isolated problems like write a function to validate email addresses. You get thoughtful solutions with error handling and good documentation. But here's where it breaks down. The AI doesn't know that your team uses a specific logging framework, follows particular error handling patterns, or has performance requirements. The AI gives you clean, generic solutions that work in isolation. But generic is the problem. You get console log. When you need your Winston logger, basic error throwing. When you need your custom error classes. Simple assertions when you need your jest setup with specific matchers. The solution works, but it doesn't fit your code base. Integration becomes a manual translation process. Let's talk about the economics nobody mentions up front. Current pricing for quality models like GPT-4 or Claude, when using their API, can run $3.15 per million tokens. And a medium-sized feature request easily consumes 200 or 500 tokens between your prompt and the response. That's $2.08 per request. For a team doing serious development, you're looking at $200, $1,000 monthly. Local models are free after your hardware investment, but they're significantly behind in quality and require substantial setup time. Let's destroy 2 dangerous myths about prompt engineering. First myth: prompts are just that sentence or two you type at the beginning. Wrong, dial. Your entire context window is the prompt. Your initial instruction, any code examples you paste, documentation snippets, the conversation history, system messages. This can easily be 50,000 tokens, equivalent to over 100 pages of text. When developers say my prompt didn't work, they often mean my tiny instruction at the end of a massive context didn't give me what I wanted. Second myth: prompt engineering is some precise science where gurus have secret techniques. It's not. It's educated guesswork, iteration, and a lot of trial and error. Anyone claiming they have the perfect prompt formula is selling you snake oil. Third myth that kills productivity: thinking the AI remembers everything from your conversation. These models have context window limits, typically 128K to 200K tokens. Once your conversation exceeds that, the AI starts forgetting the beginning. Worse, each new chat session starts completely fresh. This is why developers who copy-paste code and context into fresh conversations often get better results than those trying to maintain long, ongoing conversations. The AI doesn't have persistent memory of your project. Every interaction needs sufficient context to stand alone. Here's the thing: these aren't mysterious AI failures. They're predictable behaviors based on how these systems actually work. Developers who understand the underlying mechanics, things like attention mechanisms, context windows, and token limits, consistently get better results than those who treat AI as a magic black box. You don't need a PhD in machine learning, but if you're going to use these tools professionally, investing time to understand their fundamental constraints will save you from repeatedly hitting the same walls. Here's what actually works. Be specific about your context. Instead of write a login function, try write a login function for our Express.js API that uses JWT tokens, integrates with our existing user model from models user.js, follows our error handling pattern that returns standardized JSON responses, and includes unit tests using our jest setup. The difference isn't magic. It's information. The third approach is conversational coding, using tools like Cursor, IDA, Klein, or Rocode as conversational coding partners. These tools can actually read your existing codebase, write new files, and even execute code to test changes. You can say, add user authentication that integrates with our existing database, and have a productive back and forth about implementation approaches. When it works, it feels magical. But there's a big reality check coming. Here's why conversational coding breaks down. You're making architectural decisions one conversation at a time without an overall plan. The AI suggests solutions that work for the immediate problem, but each quick fix creates constraints for the next conversation. It's like building a house by standing in your yard and asking, what should I do next? At every single step, instead of starting with blueprints. This is why the code works initially, but becomes unmaintainable. You're not building a system. You're accumulating a series of patches that happen to work individually. Here's the hard truth. Conversational coding is currently only viable for throwaway projects, prototypes, or personal experiments. And if you're working on authentication, authorization, or any security-related functionality, you need to be 10 times more careful with AI Assistant. These models can produce security code that looks correct, but has subtle vulnerabilities that won't be obvious until someone exploits them. Please don't use this approach for production security systems.